here today. Just looking at this, again, this kind of confused people a little bit because you have 60. The whole side here is 100. The whole side here is 70. We were told that this is 18, this is 30, and this is my x right there. Now, again, it's a matter of setting up the correct proportion. There's so many numbers here, it can be a little bit overwhelming. But again, what we want to do is we want to look at, first off, what am I looking for? I'm looking for this segment right here. So that's x. What segment does that correspond to in the other triangle? That's the whole thing. This whole segment in the other triangle, right? So 70. And we have to compare it. I could compare it to small triangle, whole triangle, or small triangle, whole triangle. Either way, it doesn't matter. I just have to choose one of the other two. I don't need to use all of them. So again, I'm going to do, whoops, undo that. I want the yellow color. Okay, I'm going to do this. Small triangle and whole triangle, big triangle. Okay, see the corresponding parts, the yellow to yellow, the green to green? That says 18 over 60. And there we go. There's our proportion. And again, by drawing over it, it's pretty easy to see once I've got it highlighted. Oh yeah, yellow to yellow is green to green. They're corresponding parts. There's my thing. I could go ahead and reduce this fraction. 18 over 60. 18 goes into 60. Well, 6 goes into both of those, 3 and 10. So I could reduce it first and then cross multiply it. So 210 equals 10x divided by 10. X is 21. And there we are, all said and done. So again, it's a matter of setting up proportions. Some people did 18 over 60 equals 30 over 100. Well, that's true, but unfortunately it doesn't help me solve for x. Or I tried doing all three ratios at once, which again really doesn't help very much. So keep an eye on that. Oh, I should mention real quick before I forget. I know some people at some point this year have borrowed a calculator to use and may have forgotten to return it. One of the yellow calculators. I'm down 5 right now from the beginning of the year. So we need those back, or there will be a second semester, then calculators will no longer be available. You'll have to check it out with a shoe or something like that if you want to borrow one. So if you have one, or if you know someone who forgot to return it, because I'm sure they just forgot to return it. I know that one's accounted for. Well, it really wouldn't do much to steal one of these bright yellow ones which say school property on them.
Scratch that up.
Yeah, the only TIs that come in yellow are school ones. They don't sell.
Take the back off, just put tape over it.
It'd be kind of obvious. We could paint it, yeah. You could just go out and buy your own calculator.
You could use your phone calculator.
No.
Then we went just during class.
During class, not during tests, yeah.
For obvious reasons. I don't use it.
Middleton High School, anyone? Thank you very much, yes. Okay, we're done.
What happened to Middleton?
Like the entire calculus class got caught cheating, because what would happen is one person would have to take the test early, and they'd take pictures of the test with their phone. They'd use their phone for their calculator, take pictures of the test, and then Instagram it to everybody.
Oh, you can't Instagram. People.
I used to do that now.
You just gotta send it, not Instagram.
They'd Instagram it or send it or attach it in emails or whatever they do. But yeah, they'd have to take the test early, and then they'd post the test on.
That's a good idea.
Yeah, no.
Well, I realized.
Let's just say the people who did it got caught. They were, they're pre-calculus students, so they're calculus students. AP Calc actually it was, not pre-calc, AP Calc. And basically they're kicked out of school, and
Oh, that sucks.
That's should've been more careful.
Yeah, you should have been smart about it.
and they were already admitted to college, and their college is probably going to rescind their admission too. So,
Senior?
yeah. So, yeah, major cheating like that, colleges don't look very kindly on stuff like that when you're looking for application. So, wouldn't plan on being very successful if that's the way you're going to be learning. All right. So anyway, that's where that one was set up. The last couple problems, 8 and 9, most people got 12, and some people had the same problem in 9 as they did on 7, but most people got 10. Number 10, people kind of like totally freaked out about number 10, and it really was very, very simple. Because the picture,
Trees don't do that.
yeah, they do.
They make a perfect right triangle.
Well,
Not a perfect triangle, if you look at just the trees or something.
it really doesn't matter because the angle's the same, but let's say it is a perfect right triangle, okay? So we've got a right angle here and a right angle here. We're told this is 8 feet, and this is 10 feet. We're told this whole length here is 28 feet.
We're actually measuring the wall.
Okay, and we want to know how long is, how long is this right here? And that's exactly what we were just doing. I mean, 8 over 28 is 10 over x. That's easy. The question is, what is the reason why we can do that? How do I know those triangles are similar? No. Because I don't know this side yet. Okay? I don't know this side. But what is the reason? Angle, because that angle's in both triangles. So for 10A, the answer was angle, similarity. And I have people saying similar postulate, or theorem 4-1, or, at least side angle, side similarity is one of the similarity theorems. I have people say HL. HL is not a similarity theorem, it's a congruence theorem. We only have 3 similarity theorems. It's like you lost your mind somewhere on this question. And like you were looking way back or thinking way too hard. It still just fits within their section here of angle, and side, and side similarity. This is this is angle, similarity. The 2 pairs of corresponding congruent angles. We're going to 90 and whatever that angle is.
What would be angle?
Again, we only need 2 angles, because if 2 angles are congruent, the third angles are automatically congruent. That's one of our earlier theorems.
Did I get it wrong? Angle.
I don't think it took off any points for it, but technically, yes, it's wrong. It's just angle. So, and again, if you had side angle side, that doesn't worry me so much, side angle side similarity or side similarity. But if you had something that was out there,
Similar angle.
yeah, no. Grasping at straws. That's really what that
Why
was.
do you have that equation on the board all of you?
Because people need it for pre-calc sometimes. Sums and difference of perfect cubes. You'll learn that one in algebra too.
That's just disgusting to think about. Mr.
It's not that bad of a formula, but it's a good one to.
What do you do in algebra 2?
Algebra,
Yeah.
solve equations, graph parabolas, graph functions, a lot of graphing
Is it easier than geometry?
for some people. Some people like algebra better than geometry. Some people like geometry better.
How did those students pick it up?
How do you think?
They posted it on
They both know
Do you think someone told on them?
Yeah, probably.
that.
I heard Carly stick that.
So, and it's also just, teachers aren't as stupid as you might think.
I haven't met a teacher who has an Instagram though.
I have.
Did you else have one?
Yeah.
Tom has one.
Tom has one.
Yeah.
If you ever looked at it.
Both of
Yeah.
them.
All right. All right, let's look at some of our review problems here.
Stuff that hasn't.
Determine if the polygons are similar. Show the math to support your answer. So I've got 2 polygons here. The question is, are they similar? And if so, support our answer using math. Well, first off, 2 requirements for similar polygons. They have to have corresponding congruent angles. So one of the things I could do to show my math is to find the fourth angle of this polygon. I've got a 110, a 90, and a 95. Well, 110 and 90 is 200, and 95 is 295. So it's 295 degrees up of this. How many total degrees would there be in a quadrilateral? 360. So 360 minus 295 leaves me 65. And then I've got the same three angles down here, so this must be 95. Okay, so all the corresponding angles are congruent. That's good. But we don't have angle for quadrilaterals. It's only for triangles, so now we have to go and show the sides are proportional. So again, we set up our ratio, shortest to shortest. Next to next, 6 and 9, 8 to 12. And we reduce them all. 4 over 6 reduces 2 to 3. 6 over 9 is 2 to 3. 8 over 12 is 2 to 3. 10 over 15 is 2 to 3. So all the corresponding angles, all the corresponding sides are indeed proportional. All the corresponding angles are congruent, so yes, those are similar. If these didn't all reduce to exactly the same ratio, they would not be similar. If all the corresponding angles were not congruent, it would not be similar. What is the scale factor of these two polygons? What is the scale factor? 2 to 3, yeah. What did they all reduce to? 2 to 3 is a scale factor. And because I didn't specify an order, I went left to right, but it really, you could have said 3 to 2 because I didn't specify scale factor smallest to largest. So there we are. Similar polygons. A little different from the triangles because I have to do all the sides instead of just the triangle parts. Triangles are actually a little easier. What else is going to be out there? Simplify a ratio is going to be out there. $48 to $20. Wow. How would I reduce that? That's 48 over 20. So that's 24 over 10 dividing by 2. Can keep going. 12 over 5. Can we go any further? Would I express it as a decimal? No. Would I, how about 2 and 2/5? No. It's a ratio. Compares quantities. Let's leave it as 12 over 5. 2 hours to 30 minutes. Ooh. Is that going to be 2 to 30 and 1 to 15? Why not? Why can't I just go 2 to 30? Because not the same units, is it? How many minutes are there an hour? So 2 hours is 120 over 30. Oh, okay, and 12 over 3 reduces to 4 to 1. Now, can I just write that as plain old 4? No, it's got to be 4 to 1. A ratio always compares two quantities. Bag of lawn fertilizers, nitrogen, phosphorus, potassium in the ratio of 28 to 10 to 15. There's 106 pounds of fertilizer. How many pounds of nitrogen are there in the fertilizer? Okay, it goes nitrogen, phosphorus, potassium, 28, 10, 15. So that means 28x plus 10x plus 15x. Those are my three things, and we're going to add them together, add the x's. Has to equal 106. That's 38, 53x is 106, so x is 2. How many pounds of nitrogen are there? We have to take that 2 and substitute back into the nitrogen formula, which is 28x, so 28 times 2 is 56 pounds of nitrogen. Well, it is. Yeah, it's in a 100-pound bag.
What is nitrogen?
It is a fertilizer component. It's an element. It's actually a gas. It's probably something infused with nitrogen.
Okay, how do you weigh gas? That's a lot of gas.
Gas has mass.
Well, I know, but like, it'd be a lot.
Weighing
Put
it
in a
can be
bag.
difficult. Yeah, put it in a bag. It's a gas at room temperature. It's a solid at certain temperatures. It's liquid at a very cold temperature.
Why would
Liquid
you
nitrogen.
freeze your fertilizer though? That doesn't make sense. Liquid nitrogen.
It's fun. You take like the puff dandelions and dip them in liquid nitrogen, and they become brittle
Have
and
an ice
pretty.
garden.
There we go. Yeah.
Let's do it.
All right, solve the proportion.
You're thinking.
Again, we solve proportions by cross multiplying. I still get one or two people who are trying to add when they do the cross. No, we cross multiply. 5 times 10 is 7 times x. So 50 is 7x. So x is 50 over 7. Do not decimalize that. Do not approximate it. You could reduce it if necessary. It does not reduce. It is 7 1/7. That's it. When I have the variable expressions, I have to be a little more careful. But again, it's just an algebra problem. Subtract the 5n from each side, that leaves me m. Add the 12 to each side equals 27. Here's something we haven't done a lot of since we came back for break. In fact, I think we've done it all, but is going to be on the test and is important. Find the geometric mean. What's the difference between a geometric mean and an arithmetic mean that we normally use to finding it? In an arithmetic mean, we add and divide by 2, right? What do we do for a geometric mean? We do not add them. What do we do?
Multiply.
We multiply them and then take the square root. Yes, multiply and take the square root. To find a geometric mean, that means multiply, then square root. So 2 times 32, square root is the square root of 64, which is 8. It is not the same as the arithmetic mean. The arithmetic is add and divide by 2. That would be 34 divided by 2, which is 17. That would be the arithmetic mean. We want the geometric mean, which is multiply and take the square root. So that's 8. 17 and 8 are not the same. If you think they are, I will give you $8. You come give me $17. We'll call it even. Any takers?
We could just get it right.
No. For 6 and 10, again, same thing. Square root of 6 times 10, which is square root of 60. However, square root of 60 doesn't simplify quite as easily as square root of 64 because 64 is a perfect square. So we got to look for perfect square numbers that go into 60, which would be 4 and 15. Square root of 4 is just 2 root 15. Now I say, well, yeah, 15 is 5 and 3. Yes, that's true, but neither of those is a perfect square, so it doesn't help me. But again, in a test, just getting here is probably worth 2 out of the 3 points. Simplifying it is how you get your last point. So make sure you understand the process of geometric mean. It's multiply and take the square root, not add and divide by 2. For like arithmetic mean, it is different. Rewriting proportions, we've done this before. If a over b equals x over 6, then b over a would be what ratio? 6 over x. If then a over x would be b over 6. And this is always a tricky one. X plus 6 over 6 equals over b. Yeah. We add 1 to each side. A solve for x given the information. Again, pretty straightforward. I do have to find the whole thing here is 21. But again, once we've got that, then I get 11 over 15, or 11 over x is 15 over 21. So that's 210, 221. divided by 15. And x equals 221 over 15. That's what we come up with. That seems off. Did I do that right? 11 over x equals 15 over 21. Yeah. 11 times 21 would be 210. 10 times 21 is 210. Plus 21, 231. Sorry. And that will reduce. 231 over 15 does reduce a little bit. Because 2 plus 3 plus 1 is 6. So 3 goes into that. So 231. 77 over 5. That'd be, oops, wrong way. Woo. Try that again. Yeah, it came out a little bit funky, but that's what happens when you make up the number sometimes. Solve these triangles given that they are similar. Solve for all the unknown parts. All right, well, let's see what we can do. We're given a similarity statement, so angle A corresponds to angle X. So what does the measure of angle X have to be? 85. Angle B corresponds to angle P. Angle P is 50, so angle B must be 50. And 85 and 50 is 135. They add up to 180, so that must be 45 for this last one. Then I can set up proportions. We got to know which side goes with what. Well, MX goes with CA. I don't know that. MX is CA. So MX is 7 is CA. That's unknown. AB goes with XP. Aha, AB is 10. XP is 6. Now I can solve that. So 10 times CA equals 42 divided by 10 is 42 over 10, or 21 over 5. Okay. No, that's not. I'm sorry. No, I wasn't solving CA there, was I? What was I solving? 7 over CA, AB over XP, AB, XP, okay, yeah, equals 7 MX over CA. No, that's right. 21/5. That's right. So there we go. I could solve the other side too. So these are the kind of problems we're going to come up with. A lot of the stuff from tomorrow, a lot of the stuff from beginning of the chapter, that's just going to be on the test. Geometric mean will be there. I guarantee you that geometric mean will be there. So let's practice it one more time. Geometric mean between 5 and 15. So geometric mean between 5 and 15. How am I going to find geometric mean? Multiply it and then square root. So 5 times 15 is 75. Square root of 75 is my solution. However, I need to simplify that. What perfect square goes into 75? 25 times 3. Root 25 is 5. And we talked about this first semester. First semester, it's still first semester, before Christmas. Write it all out. Don't try to do problems like that in your head. Write out every step. See the perfect square, write it in there. Write that square root of 25 times the square root of 3. Cross out the square root of 25. Use a little bit of extra ink. Make those extra pen strokes. You will reduce the number of errors that you have. Okay? That pretty much covers what's going to be on the test tomorrow. Take your quiz home. Study from it. You ready for that test? It's pretty major. It's our last test of the quarter. After tomorrow, all quarter grades are done. All makeup work is in. Anything that you're missing needs to be done. Any retakes you want to do have to be done by the end of the day tomorrow. After tomorrow, quarter's over. We only have semester exam left. Work on that packet this weekend. Maybe not so much tonight because you're getting ready for the test, but working it this weekend. Remember what you saw in your homeroom today, that the way to study for math tests is to do problems. You don't read over notes and glance at notes like you do for an English class or a history class. You actually do problems because you do math. You don't do history. You remember history. It's the difference. So study by doing. All right? Okay.